Today we'll be doing Stewart's 7th edition 6.2, question number 48, relating to volumes. The question gives us the frustum of a cone with two different radiuses r and big R, with a height of h. Now we have to find the volume of it. If we look at the solid, we can look at it another way, like a line that is being rotated around the x-axis, and that will give us the same shape. So now we're looking at this line that's being rotated. We know that we can find its volume by taking the integral from a to b, pi r squared times h. Now now we have to find the bounds of this frustum. So let's look at this line. It's at the point 0 to h because of its height, starting from 0 to h. So we have the integral from 0 to h, pi r squared. R squared in this case would be a function. Now the function of this line is given by the line equation mx plus b. To find m, we have to find the rise over the run. So we have r2 minus r1 over h, x plus b. B in this case would be the little r because that's the y-intercept. So we plug that in. R minus r over h times x plus r. This entire thing squared times that by h, which becomes dx. Okay, so now we have to take the integral of this, but before that, I'm going to FOIL this out. I'm going to move pi over here, and then when we FOIL this out, we have r minus r over h, x squared plus r minus r over h, x plus r. Now we have two of them. Or sorry, it's times r. Now we have two of them. Now, and then r squared. Okay, so now we're able to take the integral of this equation. Take the integral of this, we have 1 over 3. We're only taking the integral with respect to x because this equation is in dx. So x cubed, everything else remains the same, which is squared over h squared, plus 2 r minus r over h, x, or let's do r first, and then this x becomes 1/2 x squared plus r squared becomes x r squared because you have to add the x there. Okay, now I have the integral with respect from 0 to h. Now I'm going to plug in this h value into this equation. 1/3, this becomes h cubed times r minus r squared over h squared plus 2 r over h, r 1/2 h squared plus h times r. Now when we plug in the 0, this becomes squared. Now if we plug in the 0, everything cancels out because x here cancels out, this becomes zeroed out, and this becomes zeroed out. So the volume is left to this equation. I'm going to simplify this. H cubed r minus r, that's cubed over h squared, plus 2 r minus r over h, r, this right here and this right here will cancel out, times h squared plus hr squared. Okay, so this and this will cancel out. This right here and this right here will cancel out. So we have pi 1 over 3 h times r minus r, big R minus little r squared, plus big R minus little r. That's been canceled out. So we have times r times 1h plus HR squared. If you distribute the pi, now we have the volume of the frustum. If this frustum had values if big R and little r had real values, you would plug it in here and find the total volume. And now we're done.